Hi, welcome to Teardown Tuesday. Yes, everyone loves some vintage classic consumer technology, and nothing beats an old Motorola flip MicroTAC phone from 20 years ago, 1994 vintage, the Motorola International 7200. I've had this one for quite some time. It was sent in to my mailbag segment by Thomas Sutherlandy, so thank you very much, Thomas. Just getting around to it. Retro charger, look at that. You could have the phone or a second or two battery packs on charging this sucker. Flip. So we're one step up from the old Gordon Gecko brick, which I've torn down before, which I'll link in down below if you haven't seen that. One of those brick mobile, once again, a Motorola, because Motorola owned the market back then. But this little MicroTAC beauty, it's actually quite small and lightweight relative to the brick phones anyway, and certainly very quite usable. You could certainly, put it in an overcoat pocket or something like that. You can't slip it into your jeans pocket, barely, but geez, this was pretty state-of-the-art for the day. Early models were analog, of course. This is the GSM one from 1994, 900 megahertz International GSM model, two-line LCD display. The earlier ones had the LED display on them. I think it's 2 lines by 12 character display, and the battery just slides out of this sucker like that, and ta-da, there it is, nickel metal hydride. As I said, you could have a couple on charge there, and this is what we're looking at, a International 7200 model, and yeah, I do believe it is like 94 vintage. I believe that's probably the date there, 94 26 or 26th week 94. So this is the GSM model. Got an interface down here that's probably for a hands-free car kit. I don't remember the exact accessories for this sucker. So you were pretty hot stuff back in 1994 if you whipped out your phone and flipped it open and pulled up the antenna and started talking to someone. That was incredibly unusual to see back then. Everyone has a mobile phone. These days, a smartphone, they're engrossed in it, but back then, it was a really, really big deal, and you had to be a big deal to have one of these things, really. So, well, certainly I didn't have one back in 1993, 1994, that's for sure. So this thing was pretty much, the model for all, flip phones to come, that sort of flip phone form factor, although it's the keypad doesn't flip down, of course. I mean, they could have easily just done away with this flippy part and just had it like that, but it just looked neat and tidy, and you didn't accidentally press the power on and stuff like that, because these things didn't have a huge battery life. It's not like you get a week standby out of this thing. So yeah, just having that flap over there keeps your keypad from getting bumped, and there's a couple of volume controls on the side, and well, not much else. There's that sliding switch there. I'm not sure what that does. Is that the main power switch? I don't know. This sucker doesn't work, so or at least it's not powered up. Battery's not holding any charge, so let's crack this sucker open. Now, of course, we're going to see a lot of surface mount stuff in it. It'll be, well, all surface mount essentially, really. I'd be very surprised if there's any through-hole stuff in there at all, but nothing like the system integration you get these days. There'll be separate, RF and analog sections, a lot of that. There'll be some basic processing, but these things were, reasonably simple compared to the complexity in even just a simple modern mobile phone. They wouldn't have been running some, major operating system or anything like that. Really just, and typical purpose-designed embedded firmware product. So let's try and crack this thing open. I don't see any screws on it, so it's probably like a press fit around the outside here. So maybe if we... Hey, there we go. Could be too easy. We'll find out. And of course, Motorola, being as huge as they are, probably rolled a lot of the chips themselves for this sucker. So that wouldn't surprise me at all to see, a real buttload of Motorola parts in this thing, and I see one main circuit board down there. I can see some tantalums already, some SMD tantalums, but yeah, I'm not entirely sure. Maybe have to get in there and sort of prise out those clips or something like that perhaps. Give me a minute to work on this sucker. One little sneaky Torx screw under there, and that's about it. Ta-da! And yeah, lots of heavy shielding, and we're in like Flynn. And no real surprises at all, exactly what you'd expect to see. You know, lots of RF stuff. We've got, looks like a like the receiver, you know, the transceiver module up here, and heavy shielding everywhere pretty much else. It looks like it's a single board construction. It's going to be double-sided, populated of course, but yeah, heavy shielding on most of it. As I said, there's not a huge amount of system integration in terms of the you know, the RF processing side of things. So you know, it's, you know, these days it's just, you know, single chip off the shelf, whatever. You know, but back then you had to have all this stuff in its shielded can, and well, really messy kind of business. But that's what you dealt with back in 1994. Now, one of the interesting aspects of this is the antenna. If we take a look along there, we can see that you know, the antenna goes inside that, but it's, you know, it's just this plasticky heap of crap. If we have a look at the plastic mounting clip for all this, we can see what's really going on here. I mean, there's this coil here, which is clearly the antenna. It's coming in here, and then it's just wrapped around like that. We've got, you know, half a dozen turns or so, and there you go. If you cut open that plastic antenna, which isn't directly coupled to the other coil, you can see that it is actually, there is a spiral in there. So it is a passively coupled antenna. So it sits inside there. There's no direct connection at all inside there, but it's obviously good enough. So why they made the decision to do that, I mean, you know, you're not going to get the best performance out of that thing, but maybe you know, it was good enough, and it was robust and everything like that, because there's no direct connection to break and stuff like that. As long as the antenna doesn't physically pull out, they're going to get that coupling system to work. As, you know, inefficient as it might be, I don't know if anyone knows the actual, you know, efficiency of something, of a coupled antenna like that at 900 megahertz. Please share the data. And there's our transceiver module in there. You can see the trace there with the cap going down to ground, and there's our output socket there. And there's the main exposed chip outside of the metalwork, so that wouldn't be part of the RF section at all. So some sort of processor. I don't know, can't find any info on it. The XC3900176 from Motorola, and we'll no doubt find more Motorola parts in this thing. So I don't know if anyone does have any data on this ancient device, then please let us know. So let's try and pop off all these shielding cans. Should be able to. I can see the little clips down in there, and that's underneath the shielded can there, and we have a secondary shielded can underneath that. So whatever is under there, some sort of oscillator maybe, pretty darn important. Yes, another two Motorola branded parts there. Once again, no idea what those things are. Then we have some sort of, looks like some sort of hybrid module down in here. I don't know, some sort of filter or filter package or oscillator or something like that. Not really sure. Date code, of course, gives this thing away, 38th week 94, so certainly is 94 vintage. Got another can up there. To get these off, I'm actually going to have to get the iron out and physically remove those cans. So I may actually do that, but we've got some, you know, some RF transistors and some inductors and other passive stuff around there. But got ourselves a nice little PCB inductor in there. You can see that. Beautiful. Once again, no idea what that part is. Got some more tantalum, some more RF transistors around there. Oh, anyone got a circuit diagram for this thing? Right, we'll get this top board out here. I've prized it out, and ta-da, we do have a dual board solution, but oh, look at all the goodness we've missed on the bottom here. Whoa. So what have we got here? Well, no major surprises. Main processor, microcontroller here, MC68300 series, which is a variant of the famous Motorola 68000 microprocessor, except this one's designed for more embedded applications like this. It's I don't even think it's you can get it anymore. I think it's legacy. They've deprecated that. We've got a couple of 4 megabit flash EEPROMs up here. Yes, EEPROMs. They're actually not erasable. They're one-time programmable ROMs. So there's two 4 megabit ones there, 64K bit one there. We've got ourselves two 32K by 8 SRAMs here. So that is the basic control application. So I'm not sure what this sucker was doing over here that we saw on the top. I mean, clearly it's not a a major processing function. There's hardly any traces actually connected to that one in there. So maybe it's some sort of battery management device or something like that. I don't know. And a bit further down, bog standard 4051 from Motorola, of course, because Motorola do all your standard 74 and 4000 series logic, of course. Always have. No idea what this part over here is. If you've got any info on it, please let everyone know. This MC14447DW, though, this is an 8 to 10 bit single slope, not dual slope, analog to digital converter. So there you go. Then we've got a large AT&T part down in here. Can't get any info on that. No idea. Probably something the GSM type part of it, something to do with the protocol or something like that. Perhaps this one. Don't know. We'll have to whip some rubber off there. And then we have ourselves a PCM codec filter here, the MC1454880DW. We've got a data sheet on that. I'll link that in down below. And once again, that's a 5 volt part, and that's what you'll get with all these parts, all 5 volt technology. None of this 3.3 volt rubbish. Oh. And under that rubber, we have ourselves another undecipherable Motorola chip. And we've got, looks like, I don't know, a regulator or a transistor over here. Big ass diode. Some big ass tantalums around here, and not much else. Whole bunch of miscellaneous passive stuff. This would have been, of course, at least a 4-layer board on this thing. Reasonably advanced manufacturing technology for its day, all this stuff. But the thing is, this is why you can see that Motorola practically owned the market back then. We're talking Motorola processors. They've got their own Motorola digital logic. They've got the analog to digital converters. We've got the filtering happening over here. They've got all the other chipset integrated type stuff happening over here, all over the shop. Imagine if you tried to compete with Motorola producing their phones. You'd probably have to get these off-the-shelf chips, and well, you couldn't get them at the same price as Motorola, so that's why they practically own the market. The most interesting thing here, of course, is the AT&T chipset down there. Did AT&T make their own chipsets back then, or was it just, did they design it, have a say in it, who actually manufactured it, what foundry was it? I don't know. Back on the top side RF stuff again. This package in here is probably a SAW filter, would be my guess at the very least, right near the front end. We'll have to pop this can here off, but once again, we've got another Motorola part in there and a whole bunch of RF stuff. Well, yeah, we've got ourselves an inductor there. You can see that actually wound on the former there. Here we go. I popped the hood on this can, and this is rather interesting. Take a look at this. I mean, we've got some RF voodoo going on down under here, and look, we've got some sort of die bond attachment over there on these parts over here. These multiple bonds across this part, which is sort of sunk into the PCB like that. So these look for all the world like, you know, RF power transistors, and they're mounting them, and they've, like, you know, done them like individual die-like on these little aluminium blocks, which probably couple the heat out to the bottom side of the board there, and they've done those a couple of times. That's why you can see 3 connections on there. There's 1 pad, 2 pads, 3 pads, and same over here. So they're individual RF power transistors, and the multiple bond wires, you know, higher current, lower inductance, all the usual jazz that you would put in multiple bond wires for. So that's the best guess of what's actually going on there. Or that could be like a parallel a block of power transistors, perhaps, something like that. They're actually paralleling them up to get the extra power out of them, perhaps. But if anyone has some, you know, solid, you know, data on exactly what they're doing there, then please share it. That sort of stuff, please let us know, because that, folks, is fascinating technology right there. And we've got another die bond attachment, just jumping across there to that sort of, you know, ceramic pad there. And there's the other business going on in there. I mean, we've obviously got, you know, your regular sort of, you know, PCB-based distributed element filtering going on in there, actually creating the components with the PCBs like that. In fact, hang on, look, you can actually see the bond wire jumping across those pads in the solder mask. So look, they haven't just relied on the classic distributed element filter on the PCB. They've had to bond wire jump all of that stuff. So what on earth is going on there? I mean, you know, we're probably going to see some classic hairpin. No, there's no hairpin filters or anything like that, but basically regular distributed element filter construction in here. But all the intricacies of the bond wires and how they've tacked those over, I guess this was very early work on distributed element filters. By the way, I forgot to point out the ground system as part of this antenna as well. Actually extends out like that on this, well, it's not a fiberglass board. It's probably some sort of, you know, it looks like some sort of Teflon board or some other material. I mean, there's a solid ground plane on the bottom with some vias going across there, but and it's sort of wedged, of course, and it's sandwiched in the main board like that. So that's rather neat. So that forms, that stub there forms part of the antenna system as well as the central point down in there. It's not just your regular ground. And I've taken the metal end cap off what I thought was some sort of, you know, shielded block, but it's not. It's actually a dielectric filter. This is a big block of dielectric material. I'm not sure exactly what. And then they actually use these cavities which go through to the other side like that. You can see the vias popping out the, well, holes popping out the other side. They actually use those as resonant cavities in the dielectric material. I mean, you can see the, you know, the distributed element kind of filter work going on the top of the dielectric material up here, but they use the dielectric block to form resonant cavities as such, and this is one big tuned filter block. And just popped off another can on the main board there. We've got some PCB inductors happening around there, and another unknown device. And under the can next to that, which is hooked into this unknown chip down here, just some more passive filtering stuff. But those two sections were important enough to have cans with inside the main can. Go figure. Have a quick look at this main keypad board down here. So what's going on here with this entire block is that what I missed at the start was that there is actually a slot in the phone, in the bottom of the phone over here, and they slid in a full size, credit card size SIM card module into here, and then that detection switch is obviously detecting that the SIM card's inserted, so the firmware can, disable the functions for that. And the side switch on the side of the thing over here, that slider switch that comes in, that just helps you eject the card back out. Huge chip on board device down here. Lots of traces coming out of that sucker, of course. You can barely see them in HD there, but that would control that would just be the LCD driver, chip on board LCD driver for the 12 character by 2 line dot matrix LCD, plus it's probably doing the keypad or some keypad stuff as well, or the keypad stuff is just going through the main interface straight over to the processor. I forgot to mention, made in Germany. Beauty. Hi to all my German viewers. And this one here, made in, well, the Philippines, is the baseboard down in here for the LCD and the display from a company called 35 Systems. Wonder if they're still around. And I just checked, and yes they are. 20 years later, 35 Corp, they call themselves, still do custom display solutions and touch systems. Go figure. Now we've popped out that board there, and there's our rubber membrane keypad. Nothing special there, except that they did integrate the microphone down in that corner into the rubber membrane. That's rather nice. Get some vibration isolation there. They've got a tiny little ferrite on that, just to take the edge off that signal there, but there you go. Apart from that, we've got some tactile domes here on the top side. And there's our speaker, of course, mounted up in the top. Some regulation stuff, probably a speaker amp there, and that is pretty much all she wrote. And there's our, we can probably get a look at the, if I get the right angle there, you can see the 12 character display on that sucker. Got to get the right angle though. Yeah, look at that. And of course that would be your ringer, your buzzer slash ringer. It's, had to be, I can't remember how loud these things were. I never owned anyone, but can someone recollect if these suckers were allowed ring, 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 ring? What mobile phone ringtone did they have back in 1994, 20 years ago? I don't know. So there you have it. That's a teardown of the Motorola International 7200 MicroTAC flip phone from 1994. That is 19, almost 20-year-old mobile phone technology. Absolutely fascinating. Thanks to Thomas Salandi for sending that one in. Interesting mix of technology. All basic surface mount, but then you get into some real nasty RF voodoo stuff happening in some of these modules. All of the SAW filtering or whatever it is going on in there, distributed element filtering all on the boards. Fantastic. All Motorola parts, which you don't see these days. They come from all over the shops, almost all Motorola parts. And there's an AT&T chipset on there. I don't know if AT&T still make chips. We've got some other antenna stuff going on there, and that is a rather interesting look at an old school mobile phone. And this is where it came from, folks. A lot of people take their mobile phone for granted these days. Absolutely spectacular technology, of course, in modern phones, but it's just down to a couple of chipsets now. You don't see a lot of all of this, especially most of the board or half the board, or the whole top side of the board really, devoted to all of the RF side of stuff in there. And of course the processing in this, just a 68,000 variant processor in there, not doing a huge lot, in a basic 2-line dot matrix character interface display, and it did exactly what it was on the box. It was a mobile phone. No more, no less. So just spare a thought for the design team at Motorola who came up with this a really groundbreaking phone in terms of the the technology they were able to squeeze into this thing, and the flip phone form factor, get the power consumption low enough to use a small nickel metal hydride battery in the thing, and fantastic. This is where it all came from, folks. And if you want to discuss it, and if you have any more info on any of the chips or a schematic or something for this thing, then please jump on over to the EEVBlog forum. I'll try and put some datasheet links in down below. And if you like Teardown Tuesday, give it a thumbs up. No worries. Catch you next time. But hang on. We've got a bonus. We've got to tear down this IntelliCharge XT. It's an intelligent charger. Ta-da! There it is. Woohoo! Woohoo! Look at this old school through hole goodness. And we have an old friend. Look at this. A microchip PIC. Once again, 22nd week, 1994. It's a PIC 16C57. None of this flash rubbish. Oh, fantastic. LM399. A couple of discrete transistors. Looks like we've got a couple of Zenas and stuff around there. Another LM339, sorry. And a couple of big ass inductors up there. And that is about all she wrote. But look at that. A PIC handling the intelligent control algorithm. Love it. And that puppy has a massive 2K word program memory. Once again, one-time programmable. And 72 bytes of RAM, one lousy 8-bit timer, and that's it. No modern stuff like UARTs or ADCs or anything like that. None of those advanced peripherals you just take for granted these days. Bare bones chip would have definitely been hand-coded in assembler. None of this C rubbish. And the interesting thing is you can still buy this thing, the exact chip, the PIC 16C57 at DigiKey. They got thousands of them in stock. Like, 19 years later. This is what, is one of the major reasons you choose a manufacturer like Microchip, longevity of your parts. If they had some technical reason they still wanted to manufacture this, not a problem. Of course, Microchip don't recommend it for new designs. They'll tell you to use the 16F 57 at the very least instead of this one-time programmable one, but you can still buy it. Fantastic. Catch you next time.